right, so in 6.2, we're going to look at perpendicular bisectors and angle bisectors. And we're going to do some constructions, and we're also going to look at some theorems that involve those two things. Normally, if we were in class, we would grab a compass and a ruler, and we would do these by hand. You guys did these last year. Since we're not there, I'm not going to require you to. I did on the Canvas page, though, I did link some instructions for how you would do that. So if you do have a compass and a ruler and you want to give it a try, think back to those last year, your glory days as a freshman, and review some of that, you're definitely welcome to. Instead, we're going to use GeoGebra, which is an online app that will allow us to do some of these constructions. So if it's possible, if you have a separate device you could use, I know GeoGebra has an app you can download to tablets or phones, or even if you have another laptop. It would be awesome if you could follow along and do the constructions with me, so you could watch the video and do that. If you can't, it's fine. Watch the video, I'll show you how to do it, and then you can pause it, open up another tab, go to geogebra.org/geometry, and do those constructions. Okay, so if you'll follow along with me, I'm going to pull up GeoGebra here, and we're going to first construct a perpendicular bisector. Right? Perpendicular means it forms a 90-degree angle, and bisector means it cuts it in half. So this is what GeoGebra looks like. So you have to go to geogebra.org/geometry. Over here on the left side, it gives you all these tools you can use to construct it. These are the basic ones, like the arrow, kind of like a mouse. You could drag things around. You can construct a point, a segment, a line, a circle, and a polygon. If you click on more, though, there's a lot of other options down here. So we want to do a perpendicular bisector. So we start by making a segment. So if you click on segment, you just click where you want the 2 points, and it constructs a segment. If you want to move that around, make sure you hit the move arrow first, otherwise it will keep making new segments. So here's my segment right there. And then I want to construct a perpendicular bisector. If you click on that More button, you have these additional menus. One of them says there's a perpendicular line. This one says a perpendicular bisector. When you click on it, it gives you directions. So down here at the bottom it says select 2 points or 1 segment. So I can either select point A and B, or I can just click on the segment in between, and it will construct that perpendicular bisector. I'm going to put a point right there, and I'll show you why. Put a point right there where the 2 cross. Just to show you that it bisects it, you can measure those distances. If you come down here, there's a measure menu. Click on distance or length, and again it says select 2 points or a segment. I'm going to measure from A to C and from C to B. And what we should find, right, is that it can, those 2 segments should be the same because it's a bisector. It bisects it. So that part's 4.6, that's 4.6. We could also measure this angle right here. If it's perpendicular, that should be 90. So I'm going to come, and down here in the measure, there's measure and angle. And it says select 3 points or 2 lines. I'm just going to select that line, and that point C's in the way. Let me slide that up here. But what you should see is that it's also a 90-degree angle. Now you can take these points and drag them around, right? It doesn't matter where I put it. It should still bisect it, 4.1 and 4.1, and it should still form a 90-degree angle. Okay, what we're going to do in this unit is just discover some relationships between some properties of perpendicular bisectors. And this is really the one property you have to know. If I take a point and put it anywhere along the perpendicular bisector, so I'm just going to put it on there. And then if I measure the distance from D to A and D to B, it should be equal. So to do that, I'm going to make a segment. I'm going to go from D to A and make a segment, and then D to B and make a segment. And then if you click on the little arrow, I'm going to right click, or actually don't right click, just click on that segment. I'm going to make it just a dashed line. Make that one dashed, make that one dashed. Then I'm just going to measure those. So come back down to my measuring down here, distance or length. I'm going to click on that one and that one. What we should discover is if you take a point anywhere on the perpendicular bisector, it doesn't matter where I am, it should be equal distance, right? 6.8 and 6.8, 8.2 and 8.2. No matter where I go along there, it should be the same distance. Any point on the perpendicular bisector is equal distance or the same distance from point A and B. So that's our first theorem. Okay, so I'm going to leave GeoGebra for a minute here. I'm going to go back to our stuff we're working on here, and this is your first theorem in your book. So this is, you ought to have this included in your notes there. There's two of them. The first one says, if a point lies on a perpendicular bisector of a segment, then it's equal distance from the endpoints of the segment. So this point, first of all, right, this is the perpendicular bisector. It bisects that line, and it forms a 90-degree angle. That means that that distance and that distance are equal to each other. That's all that theorem says, which we just saw in GeoGebra. The second theorem is the converse. Converse just means you switch the if and the then. So this one says if I have a point D and it's equal distant from the two endpoints, it's equal distance from A and from B, then it has to fall on the perpendicular bisector, right? Right, it's going to be on that perpendicular bisector going that direction. So it works both directions. Okay? If it's on the perpendicular bisector, it's equal distance from the endpoints. If it's equal distance from the endpoints, then it's on the perpendicular bisector. Here's some examples of how we could apply that. So if I look at this problem, it wants me to find RS, like this segment right here. Well, check this. This SQ is the perpendicular bisector, right? It cuts it in half, and it forms a 90-degree angle. Okay, so it is a perpendicular bisector. That means that that segment and that segment have to be the same, so the answer is 6.8. Okay, pretty simple. Okay, this one wants me to find EG. So what is the distance all the way across? If you look at this point H, it's equal distance from G, and it's equal distance from E. Right? They're the same, right? They're both 24. That means that this line is the perpendicular bisector. We can see the 90-degree angle. That also means those two segments are equal. So if that one's 9.5, this one's 9.5, EG is the whole thing. If you add those together, you get, what, 19 is what it comes out to. Here's one, right? It wants me to find X. Actually, it wants me to find AD. So I need to find X to find AD. So if you look at this, I know it bisects this segment, and it forms a 90-degree angle. So that is the perpendicular bisector. That means those distances have to be the same. So I'm going to go 3x plus 14 equals 5x, and we're going to solve that. Minus the 3x over 14 equals 2x. Divide by 2, so x equals 7. If I plug 7 back in there, I get 35. I should get the same thing up there. Right, there's my answer, 35. That's what it comes out to. So this one says, is there enough information in the diagram to conclude that n lies on the perpendicular bisector? So we need to look at this and say, does n, in other words, is this segment the perpendicular bisector? Where you can see it is a bisector, right? It cuts that in half. We don't know, though, what that angle is, so we can't tell if it's 90 degrees. The only other option I'd have is if I could tell, if I knew that this segment, I'll outline it in a different color, we'll do black. If I knew that that segment was congruent to that segment, then I could prove that it was a perpendicular bisector because, right, the points on the perpendicular bisector are equal distance from the endpoints, but it doesn't tell me anything about those two segments. So on here I would say, is there enough information to conclude that? On this one I would say there is not. Okay, not enough information. Okay, I want you to try these two problems here. I'll slide it down a little bit. Actually, there's three. Try these three problems, and then I'll show you the answer. So pause the video, try them, and then come back and I'll go through them. So one says ZX is the perpendicular bisector of WY. So it tells us it is. If YZ is equal to 13.75, find WZ. So if we know it's given to us that this is the perpendicular bisector, those have to be equal. So that makes that pretty easy. This would have to be 13.75. Okay, the next one says, if ZX is the perpendicular bisector of WY, okay, WZ equals 4n minus 13, and YZ equals n plus 17. It wants me to find YZ. Well, again, if we know this is the perpendicular bisector, those have to be congruent. So I'm just going to go 4n minus 13 equals n plus 17, and solve that. So 3n equals 30, so n equals 10. Whoops, 10. It wants me to find yz, so I plug 10 back in, so you get 27 is the answer. Okay, number 3 says, find wx. So we're trying to find wx. That's this segment right here. When wz is 20.5, so 20.5. wy is 14.8, so this whole thing. And yz is 20.5. Okay, this is important because we know those two are equal. That means this is the perpendicular bisector. That means that segment has to be half of the whole thing. So if I cut 14.8 in half, 7.4 should be the answer. Okay, the second half of the assignment is on angle bisectors. So I want to show you angle bisectors in GeoGebra real fast, and then I'll show you how that works. We'll go through, and then we'll go through those theorems and do some. So I just have GeoGebra back up here. If you come back up here and just click on New, and you'll want to save that other one. I'm just going to hit Don't Save, and that should clear you and open up a new one. So if I come up here, I want to make now an angle bisector. So I'm going to first make an angle. So I'm not going to do a line or a segment because I want the angle to keep going. So I'm going to come down here, and there is a place right down here under lines where it says ray. So I'm going to go make 2 points. There's one. Go back to this point. Okay, so now I've formed an angle right there. Okay, what I want to construct now is an angle bisector. So if I come down to constructions, there's one right here that says angle bisectors. My directions say select 3 points or 2 lines. I'm just going to select these 3 points. B, A, C is my angle. So there's my angle bisector right there. So what I should see, if I come back up and measure these, right, if it's an angle bisector, it should cut that angle in half. So let's just measure it to make sure. So let's measure. I'm going to go select those 2 lines. And then I'm going to select these 2 lines. Okay, and it's kind of hard to see. I'll drag those out. But both angles right now on both of mine come out to be 15.6. And I can change the angle, right? It shouldn't matter. Those should still be the same. They should still be bisected. Okay, what I want to show you is this, is if I pick a point on my angle bisector, so put a point on there. It doesn't matter where you put it. We can move it afterwards. And if I measure the distance from that point to both sides of the angle, so let's measure the distance. So come down here. We're going to hit distance or length. I'm going to click on that point and then on this side over here. And it tells me from that point to line F, so D to F is 2.8. Do the same thing. Click on this point D. And then don't click on C. Click on the line. It says the distance from D to G is 2.8. So it comes out to be the same. And what we should see is if I move that around, that distance stays the same. One thing I do want to point out, we talked about this before, but when we measure the distance between a point and a line, it measures the perpendicular distance. So it's measuring the distance from there to there, right? It's the perpendicular distance between those 2 sides. So keep that in mind as you measure that. That's the distance that it's actual measuring. So really simple. The second theorem, or set of theorems, sorry, this says perpendicular bisectors, right? We just did angle bisectors. The second set of theorems has to do with angle, with angle bisectors. Okay, so what it says is this, really simple, is if a point lies on the bisector of an angle, this point D, then it's equal distance from the 2 sides. So that distance and that distance is always the same. The converse is also true. If you have a point D and it's equal distance from the 2 sides, that means this has to be the angle bisector. Okay, so if it's on the angle bisector, it's equal distance from the 2 sides. If it's equal distance from the 2 sides, then it has to be on the angle bisector. So here's a couple of examples that go along with that. We want to find the measure of GFJ and find out what that's equal to. Well, if I look up here, this looks like an angle bisector. Make sure we know it is. So there's my point that's equal, that distance is the same on both sides. That means this has to be the angle bisector. So if that's 42, that one's 42. We've got our answer. We want to find the measure of RS. So RS is this side over here. Okay, so this looks like an angle bisector. The question is there enough information to know that? And they have these two little marks. That means those are equal. That means that is the angle bisector. That means that these two segments have to be equal. So I can go 5x equals 6x minus 5 and solve that. So I'm going to minus the 6x over. So x is equal to 5. It wants to find RS, so plug 5 back in. So what's that, 25? I think is what we end up getting right there. I want you to try these three. I'll slide this down so you can see them all on your screen. So pause it, try these three, and then I'll go through them with you so you can check your answers. All right, so 4 says BD bisects ABC. That means we know this is an angle bisector. DC is equal to 6.9. So 6.9 over here. Find DA. Well, if it's an angle bisector, that distance and that distance have to be the same. So that's also 6.9. 5, it also tells us that BD bisects angle ABC. AD is equal to 3Z plus 7. So AD right here is 3Z plus 7. We know this bisects that. And CD is equal to 2Z plus 11. Okay, so those two are, and we know those two are equal because it's an angle bisector. Find CD. All we're going to do is set those equal. 3Z plus 7 equals 2Z plus 11. You know, so I think we end up with Z equals 18, I think, when you solve that. Okay, number 6 is a little bit different. It says find the measure of angle ABC when AD equals 3.2. So this segment right there is 3.2. CD equals 3.2. And DBC is 39. So DBC right here is 39 degrees. Well, if you look at point D, it's the same distance from both sides. That means this has to be the angle bisector. So if that's 39, that one is 39. And it wants me to find this whole angle. So 39 times 2, right? It's end up being 78. Oops. Sorry about that. It says a soccer goalie's position relative to the ball and the goalpost forms congruent angles. So congruent angles, that means we're saying those two are congruent right there. Will the goalie have to move further back? Will the goalie have to move farther to block a shot toward the right goalpost R or towards the left goalpost L? Since that's an angle bisector, we know the distance from the goalie to the left goalpost that way, right? That perpendicular distance and that perpendicular distance have to be the same, like those are equal to each other. So the answer would be the same. You'd have to move the same distance going right or left. Hey, there's one other type of problem in this assignment. I'll show this to you real quick here. It says write an equation of a perpendicular bisector of the segment with endpoints P. So it's right here at -2, 3. And Q with the endpoints at 4, 1. So they have it drawn for you right here, and this, actually, they have the answer for you. So that's kind of lame. Let's try a different one. So I have a second problem here. Let's do this one instead. So let's do number 8 right here. So it says write an equation of the perpendicular bisector of the segment with those endpoints. So let me go through this process with you so you can see how this works. Let me just grab a graph. I would suggest on all these, draw a graph. It will make it easier. You could do it without it, but it's just easier if you have the graph there in front of you. So, okay. So let's go ahead and graph that. So my segment goes from -1, -5, right there. 3, -1. There's my segment right there. Okay, and I want to construct the equation of the perpendicular bisector. So if you're picturing this, right, it's got to be somewhere coming down this way. So to find that, there's two things you have to know. We have to make sure we split it in half. That means I got to find the midpoint. Okay, I gave you that midpoint on the last assignment. on the last video, but the formula is x2 plus x1, or x1 plus x2, it doesn't matter, and y2 plus y1. So let's find that midpoint. If I add my two x's together, negative 1 plus 3 divided by 2, negative 1 plus 3 is 2, 2 divided by 2 is 1. So this is my midpoint. 1, comma. And then the y coordinate, add the y, is negative 5 plus negative 1. So negative 5 plus negative 1 divided by 2. That'd be negative 6 divided by 2. That's negative 3. So there's my midpoint. And that looks right at my picture, right? That looks like that'd be the middle of that line right there. Okay, now I'm trying to find the equation of the line. To find the equation of the line, you have to have a point. We've got a point, and you've got to know the slope. Well, if two lines are perpendicular, their slopes are opposite reciprocals. So what I'm going to do is find the slope of this line. This one is, it goes up 1, 2, 3, 4, and it goes over 1, 2, 3, 4. So the slope of that line is 4 over 4, or 1. Okay, the slope of the line I'm looking for is opposite reciprocals. That means you got to take the fraction and flip it over. If I flip 1 over, it's still 1. And then I got to switch the sign. So the slope I'm looking for is negative 1. Okay, now I just have to find the equation of the line that fits that. There's two formulas you can use. This is going back to Math 1. You can use this one if you know the y-intercept. Or if you just have a point like we have, we can use this formula. Y minus y1 equals m times x minus x1. So we're going to use the second one because this is not the y-intercept, but it is a point. Like that's my x1, and that's my y1. And there's my slope up here. So let's plug everything in. I go y minus negative 3 equals my slope times x minus my x coordinate, which is 1. And now I'm going to erase this. I'm just going to put that into the y equals mx plus b form. So it'd be, that would change to a plus, y plus 3 equals distribute negative 1x plus 1 minus the 3 over. So y equals negative x minus 2. That would be the equation of the line. So across at negative 2 and the slope was negative 1, you know it was going that way. And that looks, that looks like it would fit that line that we did right there. Okay. So that's finding the perpendicular bisector given the endpoints of a segment. Thanks, guys.